In this lesson, you will learn what is meant by performance standards, how performance standards are derived, and the purpose they serve. Performance standards are laid down by aviation authorities in two principal ways. The first is a level of regulation which ensures that the aircraft is airworthy, in other words, safe to fly. These are the certification specifications and are set out in the document from EASA called CS25. The second level of regulation is to ensure that the aeroplanes are safe enough to operate in the public transport role. That is, they are safe enough to carry fare-paying passengers. These are the operational regulations. Both of these performance standards together aim to achieve an appropriate level of safety. What is an appropriate level of safety? This is a difficult question to answer since some performance-related incidents involving passenger-carrying aeroplanes are actually very minor and do not dramatically affect the aeroplane or its passengers. Whereas other performance-related accidents are catastrophic, causing massive structural damage to the aeroplane and loss of life. It is therefore essential to enforce safety regulations of a stringency which will ensure that the possibility of a passenger-carrying aeroplane suffering a catastrophic performance-related incident is so small that it will hardly ever occur. To this end, the authorities have laid down guidelines appropriate to the consequences of various possible performance failures. Looking at the information on screen, we can see that if there was a performance failure which resulted in a hull break with multiple fatalities, this would be classified as catastrophic. The possibility of catastrophic performance failure must be so small that it should only occur once in more than 1 billion flight hours. Aeroplane manufacturers must abide by performance regulations laid down by the authority in order for the aircraft to be given its certificate of airworthiness. For example, large aeroplanes, principally Class A aeroplanes, must abide by the certification specifications laid out in EASA in the document CS25, and Class B must abide by the certification specifications in CS23. To achieve this, rigorous testing of the aircraft must take place by the manufacturers. It is a very lengthy and costly process, but one which is absolutely vital for safety. These pictures show various aircraft being tested under various conditions. The scope and depth of regulations are extremely detailed, but the certification specifications for Class B are not as stringent as for the Class A. In order to gain an airworthiness certificate, a brand new Boeing 737 would have undergone a far more rigorous set of tests than a Cessna 172, and yet both could potentially be used for public transport. Therefore, a disparity in the level of safety exists between the types and classes of aeroplanes, even though they may be used for the same purpose. This situation has been addressed by the aviation authorities laying down another set of performance regulations, applicable only to aeroplanes that will be operated for public transport and detailed in JAR Ops. These are the operational regulations. JAR Ops Part 1 prescribes requirements applicable to the operation of any civil aeroplane for the purposes of commercial air transport. Since Class B aeroplanes are not subject to very stringent certification specifications, they therefore have the very strictest operational regulations applied to them. This was briefly mentioned in the previous lesson when we stated that single-engine aeroplanes are not allowed to operate as public transport at night or in IMC. Class A aeroplanes, on the other hand, are subject to very stringent certification specifications and will, therefore, have the least stringent operational regulations applied to them. They are allowed to operate even in the poorest conditions. To summarize, CS25 and CS23 are the certification specifications for Class A and Class B aeroplanes respectively. However, if these aeroplanes are to be operated for public transport, then they must also abide by JAR Ops Part 1 as well, which constitutes the operational regulations. The certification and operational requirements together aim to ensure that there is only one chance in over 1 million that an aeroplane will not be able to meet the minimum performance standard required for a given mode of operation.
Throughout this course, and in all performance regulations, you will come across a variety of different expressions of performance that need to be understood and explained.
Going through these will also help to clarify some of the ideas we have already covered. The first of these expressions is measured performance. Earlier on in the lesson, we mentioned the rigorous testing that aeroplanes go through before they are issued with an airworthiness certificate. A large part of these tests involve discovering the aeroplane's performance capabilities. These include finding out its average takeoff distance, landing distance, climb gradient, range, and so on, under a variety of different weights and environmental conditions, with a brand new aeroplane flown by a highly skilled test pilot. These particular performance figures gained by the manufacturer under strict test conditions are described as measured performance. However, measured performance values are an unrealistic representation of what may be achieved under airline operating conditions. This fact makes measured performance values somewhat meaningless to the airlines. Airlines do not always have brand new aeroplanes, and their flight crews are not all test pilots. Therefore, it seems obvious that another set of performance values are needed to more accurately account for this variation. To more accurately reflect reality, the measured performance values need to be reduced by a factor which reflects the condition of a representative operating fleet of airplanes flown by line pilots.
When this factor is applied, we get what is known as gross or demonstrated performance. Gross or demonstrated performance is defined as the average performance that a fleet of satisfactorily maintained airplanes flown by an average pilot can be expected to achieve.
To help understand the difference between measured and gross performance, we will use an illustration involving an aeroplane landing. Shown on screen is a representation of a landing using the measured performance values, which, if you recall, is flown by a test pilot in a new aeroplane. However, we mentioned earlier that this was unrealistic. So if we now carry out a landing using gross performance figures, based on an average pilot with an average aeroplane, you can see that the landing is not as good. This time, the landing has used up more runway. The average pilot, in his average aeroplane, has not performed as well as the test pilot with his new aeroplane. This image, comparing measured and gross performance, gives you a much clearer idea of what the different performance values mean. You will probably appreciate that it would be far more prudent to use the gross performance data rather than the measured performance data, since gross performance is the performance that most pilots would achieve. However, even though gross performance values are more fully representative of operating conditions, there is still one more issue concerning gross performance which is a concern. We now appreciate that a talented, well-rested pilot with a new aeroplane will perform a better landing than that represented by the gross performance shown on screen. But from what we have learnt so far, we may also deduce that a less able pilot, who is perhaps tired and flying an old aeroplane, will perform even worse than the gross performance. this is a potentially hazardous situation, and as demonstrated in our example on screen, would result in the pilot almost running out of runway, endangering the aeroplane and its passengers. If the published landing data in the aeroplane flight manual was the gross performance, the pilot in this case would not have achieved it, and thus will have compromised safety. He was expecting to perform as in accordance with the manual. So even though gross performance is a more useful and realistic indicator than measured performance, we must ask ourselves, is even gross performance good enough to use in a typical airline environment? The answer, as you will probably have surmised, is that gross performance is not good enough. It just does not provide enough safety standards for public transport operations. What safety standards should the authorities enforce? Should the authorities take account of a bad landing every now and then and set a level of safety that allows for that, and include these values in the aeroplane flight manual? Is that good enough? Or should they take into account the worst landing in every 1,000? Or even every 100,000? Would that be good enough? Well, we mentioned earlier on in the lesson that the authorities aim to set a level of safety to take into account the worst case in every million. This level of safety is, in fact, the level taken as the safety standard for normal airline operations. The performance standard which represents this level of safety is called net performance.